Thank you for coming. And the topic today is sentiment analysis by NLTK. So this is my slide. In case you cannot see the slides clearly, you can download the slide directly. So the topic today is about sentiment analysis, but we will not cover the complex part. I only want to show you what is sentiment analysis, what the concept behind that, and how can we begin to play the sentiment analysis. So what is sentiment analysis? It's aimed to determine the attitude or the emotion from the speaker with respect to some text. So basically, it means that we go to Amazon's customer's website. You can see some review. So we want to use the sentiment analysis to check whether the customer provide positive reviews or negative reviews. For Twitter, you can also use the sentiment analysis to check your followers' replies. So in case you are a celebrity, you have thousands of followers, you cannot check all of the replies from your followers. So you want to use some techniques to check whether our followers like our product or not. The very basic way to check to do the sentiment analysis is to just distinguish the sentence and check whether it's a positive one or a negative one. For example, this is a good book. You are human, you can know that very easily. This is a positive sentence. This is a good book. I like it. It's slightly more positive than the last one because you found there are two positive words there. And the third one, this is a bad book. It's kind of a negative one because it contains a bad there. The last one is it's more hard for machine, but easy for us. The first chapter is good, but the rest is terrible. For a human, we can easily know that, wow, that book is terrible. But for a machine, it's not easy to know it's negative because the machine found that there are two words about the sentiment. The first one is good, the second one is terrible. So you have to use some algorithm to check whether it's negative or positive. So how to use the computer to compute that? Yes, you can use the Scouter. Does anyone know what is this? It's about the comic. It's a cartoon about 20 years ago. So 20 years ago, it's called Scouter, and today we call it Google Glass. So, so imagine you build a Google Glass, and when you see a sentence, you can know, wow, this is a positive review. Oh, this is a bad review. So we want to build a tools for us to check whether it's a good or bad. So why is sentiment analysis so useful? Think about if you are author in Amazon and you publish a book, and one of your customers say, this is a terrible book because it's important. So I want to mention this 3 times. Terrible, terrible, terrible. In this case, wow, this is super important because maybe this customer is your target customer. So you want to figure out what problem is. Maybe you can communicate with the customer directly. Maybe you can find your teammate to figure out what happened together. So because sometimes there are lots of reviews or lots of replies, so it's not easy to read all the data. So you have to use sentiment analysis to help you to figure out whether this customer provided a negative one or whether this customer provided a very, very, very negative one. So let's begin with the very easy way. There's no machine learning now. This is a very easy way. So we try to build a sentiment dictionary. This one is the very easy one. So think about like. Like is a good word, is a positive word. So we give it a score 1. The next one is good. It's slightly better than like, so we give it a score 2. The next one is bad. I think this one is not so good. It's a negative one. So we give it a -2. And the last one is terrible. I think it is worse than bad. So we give it a -3. This is a very simple sentiment dictionary. How can we use that to compute our sentence? The first one, when our machine read the data, this is a good book. Then it compared to the dictionary, and we found that there is a good there. So we give it a score 2. So score is larger than 0, so it's positive. The second one, this is a good book. I like it. So we found a good score 2, like score 1. So we sum them, so we get a 3. It's positive, and probably more positive than the first sentence. The third one, this is a bad book. Oh, we found a bad is the negative word, so yeah, this sentence is negative. Last one, the first chapter is good, but the rest is terrible. Okay, the good is score 2, terrible is -3, so we add them, so we get a -1. But sometimes you may say the first chapter is good, it's nice, but the rest is terrible. So in this case, we will get a positive. So it's only a very easy way to to compute the sentiment. Sometimes it's not so accurate, but it's a good start. It's easy to understand what is sentiment analysis. So if you are a beginner, I'll recommend you you can try to build your own dictionary and try to analyze the sentence like this. But we are not an expert. We are only an expert in Python. We are not expert in English, not expert in language. So we can use the one already layout, the one existed. This one called AFIN-111. So there's a guy build a dictionary about emotional words or sentiment word, and every word contains a rate. It's between -5 to +5. For example, you can see that abandon is not a good word, so the score is -2. And ability is nice, so we give it a 2. 2 is good. And we found there is abuse. It's worse than abandon, so we give it a -3. So how to use this in Python? Yeah, that file is separated by the tab, so we can simply just read all the lines and split the data by tab. This is split by tab. So we build a very, very simple sentiment analysis dictionary. So when we want to use the dictionary to compute your score, first thing to do is to lower your character, because the dictionary is all lowercase, so you have to lower the case first and then split the sentence. After that, your sentence becomes a lot of words. This is the good book. It's a string. It's an array of strings. And then you can use the sentiment analysis to, you can write a for loop to go through all the words in your words, and then try to get the score from the sentiment analysis dictionary. If it doesn't exist, you can just give it a 0. So when you count them together, you get your final score. So for this example, the score for this sentence, this is a good book, get a positive score. So this sentence is a positive sentence. Okay, this is a quick recap. First thing to do is to build a sentiment dictionary. This is from the dictionary other people provide. And the second one is to split your sentence to words. And the last one is to compute the score for your sentence. But what if the text is so long, or it has a lot of punctuation? For example, nice book, then you have a punctuation. Though it is lack of advanced topics, period, it's still good for beginners. Oh, so when you want to use the speed to speed this sentence or speed the text, you have to determine what delimiter you have to use. So it takes a lot of time. And doesn't work. It's a little bit strange because the book contains the punctuation. So it's a little bit strange. See here? There's some punctuation here. Though there's a period here. When we are doing the data science things, most of the time, 80% of the time, we spend preparing the data, and the rest of the time complain about why we have to prepare that. Yeah, this is true, but NLTK is going to help you. So this is the topic today. NLTK denotes Natural Language Toolkit. It's not a system. It's not a server to receive the data from client and output something. It's only a library, so you can combine the natural language toolkits with other systems to compile your own natural language processing system. And it works with Python 3. Yeah, it's good. So first thing to mention in the NLTK is it provides a lot of tokenization tools. What is tokenization? In natural language processing, tokenization means that you want to break a sentence or break a text and into a lot of words or phrases or symbols, or we call it tokens. So NLTK provide a word tokenize function. So when the input is a text or it's a sentence, it will help you to separate the sentence correctly. And you might think that why we need this. Sometimes this punctuation is slightly has more meaningful than the period one. Yeah, this one and this one sometimes it's a little bit different, but because we are only give an introduction today, so we are not processing the punctuation today. But I would say this is a good information. So after using NLTK to tokenize your sentence, then you can do the sentiment dictionary. You can use the sentiment dictionary to count the score again. At this kind you get a 3. Nice book. Nice is a positive one, though it is lack of advanced topics. Lack is the negative one. But it's still good for beginners. Good. So the overall score for this sentence is the positive one. But it seems like we lose some information. Think about when we use our very basic algorithm to compute that. Yeah, we get a positive 3. Yeah, we know this is a positive sentence. But sometimes we will not only build only one model to compute the score. We may compute lots of models and finally combine them together. So if this model can provide more information, it's better. It's easier. It's better for further using. So it's better to keep more information. For example, this sentence contains 2 positive words and 1 negative word, but the outcome only says that it's a positive word. What if we separate the text first, separate it to 3 sentences, and then analyze them one by one? So now we know that it's this text contains 3 sentences. The first one is positive. The second one is negative. The last one is positive. You now have more information. When you get this outcome, you can use another model to compute a more accurate computation. But how can we split the data? How can we split the text to sentences? Think about there are lots kind of punctuation. There are maybe some numbers there. So maybe you have to use a regular expression, or you have to use a lot of split function. It doesn't work. So NLTK again. The second function I want to show you is the sentence tokenize. If you use the sentence tokenization, and the original text will be separated to 3 sentences. The first one is a nice book. The second one is elect of advanced topics. The last one is it's still good for beginners. Oh, it's cool. When you are using, if you have to use split to build a tokenization to tokenize to split a sentence by yourself, it is terrible. Trust me. It allows so many kind of punctuation you have to deal with. So, to compute the score for each sentence, first thing to do is to separate your whole text to 3 sentences. Then you can, for each sentence, you can use the word tokenization to split the sentence to words. Then we can compute sentence one by one. So now and after this, you can still sum them together, get a final outcome. But at least you get more information now. But we still miss some information in another case. This case is the first chapter is good, but the rest is terrible and confusing. It's a bad idea to buy this book. It's a common review. And if we separate to 2 sentences, we found that the first one is negative. Yeah. The second one is still negative. But at least the customer mentioned something good. Yeah, the customer mentioned that the first chapter is good, but our result doesn't contain that part. So is it possible to contain that? Yes. We can just count the positive word and negative word separately. So the first sentence becomes positive 3, negative -5. And the second sentence becomes, it's still the same, negative -3. Yeah, in this case, you have more information. You have more information than just negative and negative. So in Python, you just need to, when you get a score from the sentiment analysis, if it's larger than 0, then we add to the positive 1. And then if it's negative, we add to the negative 1. So finally, we'll get the result is, the first sentence get the positive 3, negative -5. The second sentence contains no positive word and -3 negative word. Okay, so you must start to think about, wow, but the dictionary is out of date. You probably need more words. And sometimes when you are in the domain specific, when you are in maybe the basketball Twitter group, and the term they use are different than others, slightly different. So maybe you have to train your own dictionary. You have to give the different score. Yeah, so instead you need a machine learning. I will not talk about the detail about machine learning, but machine learning is you can think about you have a lot of training data. This is a typo. You have a lot of training data, and label means that this label is labeled by the human. I will give the example later. So when you build a model, it's an empty model. You can feed the training data to the model. And after that, your model becomes smarter. So after that, you can feed the real data into your model. the model will predict the whether it's positive or negative for you. For example, our training data, when we get originally we collect the data from the from your Amazon's product page, you get the 4 sentence. This is a good book. This is an awesome book. This is a bad book. This is a terrible book. Okay, and then you can label that 4 sentence by your own, or you can find other people to help you. So the positive, negative is they are labeled by human, because machine learning is about you help the machine to learn from human. So you have to give the machine some example. So this is an example we want to give our computers. So we will fit. In real case, you will fit thousands of examples to your model. Model is, you can think it's a kind of an algorithm, but it's a stupid algorithm. So you have to feed some data to that model. So the model become smarter. After the model becomes smarter, you can give the sentence to the model. This is a good article. Then this time we will not give it the positive or negative. The trained model have to predict whether it's a positive or negative. If the model trained well, the outcome should be the positive, because we found that this is a good book, it's a positive word, and it contains a good. So we hope that this is the good article. We hope that our model is smart enough to predict that this is a good article, it's a positive sentence. Okay, so if you want to use the NLTK to do some very simple machine learning works, you have to transfer your sentence to the format for NLTK. It's not so hard. For example, this is a good book. In NLTK, we have to convert it to a Python dictionary. You just the key is the word, and the value is just the boolean. And here it just simply is true, because this is a book. So you have 4 key, and the values are all true. This is what the format NLTK use. So we have to provide the data. We have to provide the training data first. So this is the first sentence we collect from the internet, and we label by human. We know that first sentence is positive, second sentence is positive, the last 2 are negative. So we use the array to contain all the data now. Then this is the format for our training data. Now we can build a model. There are lots of model can use. So in real case, you have to try a lot of model, try a lot of parameters. But here, I only want to show you the very basic one. It's called naive-Bayes classifier. It's a general usage machine learning algorithm. Forget about that part. Think about it's a model. So this model is provided by NLTK, so we can import it directly. When we import it, the first thing to do is to train that model. So we can, the training data is the one we just generated. So we train data, oh, it's a typo, sorry. Train data to the model. So we get a model. In this moment, this model is a trained model. It have already known that 4 sentence are negative or positive. So after you have the model, you can use the classifier. You can think it is the predict. So when you give a new sentence to him, this is a good article. Then that model can help you to predict whether it's a positive or a negative sentence. And because that the new sentence contain the good word, and it's our model have already learned that when we feed the training data for that, so it can distinguish, well, this is the good article. It is a positive sentence. So we still have some time. Let me show you a real case. This case is this is about a movie review data. If you are interested, the link, you can follow this link and download the data. This data provide about 5,000 positive reviews and 5,000 negative reviews. That reviews is why is it positive or negative? It's labeled by humans. So this the other people have already labeled whether this review is good, this review is negative, is positive. So this is a very good, very easy to start with. This is the positive part. It contains a lot of that file contains 5,000 sentences, and every sentence is positive. And you will have another file. It's negative reviews, and it will contain 5,000 negative reviews. So we want to use this data to train a stronger model. Okay, the first thing to do is we have to read the data from that. And because the data is ASCII code and we're using Python 3, so I think I have to we have to use the encoding to transfer the text. And we separate the data to positive data and negative data. And when we read the data from that, we use the format sentence. Remember that it's a format that NLTK want. So we use the format sentence, the function we just built, to transfer that. Okay, now you get about 10,000 reviews. Half of them are positive, half of them are negative. And you have to separate that data to two parts. The first part is training part, is to train your data. And the remaining part is testing data. It is used to check whether your model is good or not. So we just separate it to two parts. The first 4,000 positive reviews and first 4,000 negative reviews, we added into the training data. And that's 1,000 reviews from the positive one. And the last 1,000 reviews from the negative part, we added into the testing part. So you can use the training data to train your model and use the testing data to confirm that whether your model is good enough. So we have already know how to use the very simple model, the naive Bayes classifier, to train your model. So we can feed our training data. It contains about 8,000 reviews. Half of them are positive, half of them are negative. After that, this is a new sentence. We mentioned that this is a nice article, and this model already know because this model is already trained, so it knows that it's a positive article. It's a positive sentence. The second one, this is a bad article. So your model now already know what is your model now know this is the negative sentence now. And normally when we are doing the machine learning works, we have to confirm whether the model is good enough. One of the easiest way is to just compute the accuracy. It's you predict you predict a lot of time. You just count how many times it is correct, and you divide by the total number. And NLTK have already provided lots of metrics, so you can use that together. You can use it easy, and the one we use is accuracy. So you can just import that from NLTK, and you can call it directly with the first parameter is the model you just built. The second parameter is the testing data, the one which separate from the original data. So the score is 0.77. It's not very accurate, but I think it's good. It's a very good start. It means that if you use your model to compute 100 sentences and 77 sentences are predict correctly, and the rest of them are predict incorrectly. So that is a very simple introduction about the sentiment analysis. You probably want to enhance that. There are lots of ways to enhance that. I will not teach you how to do that because it takes a lot of time and a lot of work. I can just show you what's the way to fix that. The first one is probably you can use only the most frequent word, because the model we just built contains all the words, but you can just collect all the text first and then compute the term frequency. This word is used very oftenly, so we want to give it more weight. We want to use that to build your model. This is the first way. The second one is you can choose to a different model. Maybe you can, if you know it's SVC, support vector machines classifier, or you can use the linear one, linear classifier one, and you can try lots of different model, and you can use a lot of different parameters to train your model. Yeah, this is very interesting, but take a lot of time. If you are more interested, you can read the latest paper. There are lots of sentiment analysis is still active research. So there are thousands of papers about the sentiment analysis, and maybe you are interested in deep learning. You can take a look at deep learning. Deep learning is a very powerful tool for analyze the language, but it's not so easy to learn, and you need to have a lot of computing power to do that. Okay, so I think it's my talk. So if you have any question, you can let me know.
Okay, thank you for introducing us. NLTK can do so much things. I have a question or comments, and I think you presented that to do some classification task, you need to do some training and testing. And in my viewpoint, if you do some so-called feature extraction, I think that is quite important. I means that, for example, if you present that this is a good book and that is a bad book, the whole sentence, I think the most important thing is the keyword good or bad. So if you can do some so-called feature extracts, I think that will significantly improve your performance very much.
Okay, thanks. And yes, and you just mentioned that feature extraction to get this first one use the most frequent 1,000 words only. It's kind of feature extraction. Features means that in this one it means that how many words are in your dictionary. So if you can contain original, you might have thousands of words, but sometimes it will overfitting to your model might be overfitting. So sometimes we can just cut some useless words. So it's feature extraction. You only extract some of the more important part. You can also combine the human-made dictionary and your model to build a more stronger model. Thanks.
Thanks for the talk. It's pretty awesome. So I want to ask, how would you discover that there would be different populations within among the user reviews? So before you build a model, if you already know that there are different groups within that user group, and then it's very likely their review behavior will be different. Right? How would you approach that issue?
So sorry, you mean that?
Okay, so let's use an example for like, say there's some movie watchers who really like Mission Impossible 3. So that's like group A, but there will be group B who prefer something more independent film. How could you cluster those? Like, how would you know if they exist such a like division?
Okay. Um, when you are using the model to when you feed the data to the model, if you only want to build a dictionary for your basketball group, then you can collect only the data from that group. Then it will contain more basketball specific terms in those data. So the dictionary you build, it's relative to those data. So and then you can collect another data from another group and build another model. Then if you know the detail, yeah, I believe that if you want to do more deeper works, you have to read the paper about the the algorithm, and the algorithm may contain some inner structure to mention that this word are important. This word there's maybe the array there. Then you can check the some information from that. Okay.
Hey, thanks for this talk. All the examples you gave were in English, and I think it applies pretty well to other Western languages. But what about Chinese? Because, for instance, when you want to tokenize a Chinese sentence, it's very hard.
Yeah.
And a lot of Chinese words are made up with usually 2 characters or more. So,
Yes. Yes, Chinese and maybe Japanese are harder than English. So you have to find you can build your own dictionary about the Chinese tokenization, but you can find some um, there are some exist dictionary about the Chinese segmentation or maybe Japanese segmentation. You have to use that to separate your sentence to a lot of token first, and then do the similar things. Yes. So
is there already something like that
I
with the
can show you
NLTK?
that there.
Okay, thanks.
I can provide a comment. We are in a Silicon Academy, right? So actually, there's a research group or lab. I'm not sure which one located right now, but there are a lot of publication and data talking about the tokenizer for Chinese. Yes, and you can Google that.
So how about negation? So not good or I did not like it. So that kind of negation, how can this detect such meaning?
So sorry.
For for negation, so like if the comment is I don't like this film, then don't like is negative, right?
And you can build a dictionary about the negative words, not design. So it's a very simple approach, but it's a good start. You can build a dictionary about that. So when that sentence contains a not, you just multiply -1. Yeah, I think it's a very, very simple approach, but it's a good start. And I can discuss with you the more deeper, more hard part later. Thanks.
Okay, so the session is over. Thanks again for the speaker.